So acid-base reactions. We talked about precipitation reactions, and acid-base reactions and gas evolution reactions are two other classes that can happen when we switch anions and cations. So an acid-base reaction, as the name implies, is the reaction between an acid and a base. Also called a neutralization reaction, because the acid and the base neutralize each other. They're no longer acidic or basic. A gas evolution reaction produces a gas, and this is often seen as bubbling or fizzing. So when we dissolved the copper wire in the nitric acid and we saw this brown smoke and fizzing and bubbling, right? That was a gas evolution reaction. Many of those are also acid-base reactions. So reactions can fall into more than one category. So there are multiple definitions of what an acid is, and this is the definition that we've been using. It's the Arrhenius definition, a substance that produces hydrogen ions in aqueous solution. So here, hydrochloric acid, it's a strong acid, dissolves in water, forms hydrogen ions and chloride ions. Actually, what's going on, though, here is that hydrogen ion, let's back up and think about this. How many protons does a hydrogen atom have? 1. And it doesn't have any neutrons. And how many electrons? 1. So when it becomes H+, it loses its electron, and all that's left is a proton. That's way smaller than an atom. I think of hydrogen ions as being like newborn babies. Do you see newborn babies walking up and down the sidewalk on McKinley? No, of course not. You're going to see them being held by their parents, right? They're too small to go out alone. Hydrogen ion is really too small to go out alone, and it actually doesn't. What really happens is that hydrogen ion, which is just a proton, finds a water molecule and goes for a piggyback ride. And so this H3O plus is what really occurs. So it's a water molecule with a hydrogen ion on it. And overall it's got a positive charge. It's called the hydronium ion. Most chemists are going to use H plus and H3O plus interchangeably, because just using H plus can make writing the equations much simpler. But we have to keep in the back of our mind, there's really no such thing as just a hydrogen ion by itself. That's not going to happen. It is going to be H3O plus. So acids have ionizable protons. Hydrogen ion is a proton. Polyprotic means many protons. So these are acids that have more than one hydrogen ion that can come off. So something like sulfuric acid, H2SO4, it has 2 ionizable protons here, 2 ionizable hydrogens. So 2 this is a diprotic acid. So it's going to have 2. And just, for completeness sake, it's strong in the first ionizable proton, but it's weak in the second. Arrhenius also made a definition of what is a base. A base is a substance that produces hydroxide ions in aqueous solution. So sodium hydroxide is a very common base. Dissolve this in water, we get sodium ions and hydroxide ions. We can also have some other bases like ammonia that don't actually contain hydrogen ions, but they can still act like bases, and they do that by pulling a hydrogen off of a water molecule, leaving a hydroxide behind. We're not going to worry too much about that. There are some bases that will make 2 moles of hydroxide. So SrOH2. When that dissolves, you're going to get 1 mole of strontium ions and 2 moles of hydroxide ions. But there's no cool name for that, like diprotic. There's no name for bases that do that. So acids produce hydrogen ions in solution, which are really riding on a water molecule. And bases produce hydroxide ions. The proton, the cation from the acid, the hydrogen ion, reacts with hydroxide ion to make water. And so here we see the net ionic equation down here. A hydrogen ion and a hydroxide ion. You put those two together, and if you're not, maybe you're a little tired, you might write it like this. And then you go, that looks weird. What's wrong with that? Oh, let's put the two H's together. That's H2O. Water is not an ionic compound, but this does happen. And if you just take these formulas and you put them together, the charges cancel each other out, and you end up with two hydrogens and an oxygen. So the hydrogen ion from an acid and the hydroxide ion from a base form water, and so the base and the acid are neutralized. They don't act as acids or bases anymore. Then what's left over? Well, the chloride here and the sodium there. Well, that's going to form a soluble ionic compound, sodium chloride. Salt is a word that chemists use to describe any soluble ionic compound. So NaCl is a salt. It is what we call table salt or just salt in regular life. But lots of other things are also salts. So this is showing the chemical reaction between those. I don't think that's actually all that interesting. This table shows us some common acids and bases. And here's where they finally do tell you about the strong ones. So the ones in black here are the strong acids. And here they're giving you 3 weak acids: formic acid, acetic acid, hydrochloric acid. But you'll notice it starts with an H, right? Over here, the hydroxides, the metal hydroxides like sodium hydroxide, those are going to be strong bases, meaning they separate completely into ions. They're ionic compounds, right? They should do that. And then there's ammonia, is kind of a weirdo, NH3. That's a weak base, and it forms hydroxide ions by taking hydrogens from water molecules. So write a molecular and net ionic equation for the reaction that occurs between aqueous HBr and aqueous LiOH. So they gave us the formulas, so that's kind of nice. So we're going to do the same thing we did with precipitation reactions. We're going to look at the ions that are there and have them swap partners and see if anybody, has a good time. So I think it's very helpful to write the formulas for the ions below the compounds, so you can be clear on what you have. So we're going to put hydrogen ion and hydroxide ion together, and we're going to put lithium ion and bromide ion together. Again, the order doesn't matter. In the equation. It does matter in the compound. Positive, negative. So then we're going to put these together. And that's not that's water. Right? H2O. And what's the state of water at room temperature? So liquid. You can't say that water is aqueous because water dissolved in itself. That's just water, right? And then lithium and bromide, these are also +1, -1, so just put them together. Is that compound soluble or not? It's soluble. First row, lithium, sodium, potassium, ammonium. So this one's aqueous. Then we should check and make sure that it's balanced. Now, notice this time, the hydroxide did kind of come apart. At least it looks like it did when it becomes part of this. So let's look at hydrogen. There's one there and one there. Two hydrogens. One bromine, one lithium, one oxygen. Okay. So this is the molecular equation, or you could call it the ME. And then it wants the net ionic equation. Well, we kind of have a sketchy version of the complete ionic equation right here. This guy's aqueous, that's going to be as ions. This guy's aqueous, this is aqueous. That is a strong acid, so that will be written as ions. What's the only one that shouldn't be written as ions? The liquid, right? So, that one comes together and forms this molecular compound. So we can look and see, here we have on the left side and the right side, who didn't change? Did bromide change? No. Oops. Two finger. Did lithium change? No. So what do we have left? We have H plus, aqueous, plus OH minus, aqueous, makes H2O liquid. That's the NIE, net ionic equation. That's the net ionic equation for most acid-base reactions. Any questions? Okay, we're going to do one more example, and then we'll call it good for lecture tonight. So here we're asked to write the net ionic equation for the reaction between aqueous HCHO2, a weak acid. You're not expected to know how to name that. And aqueous sodium hydroxide. And here they told us it was a weak acid, right? Not trying to trick you. So we've got HCHO2. And we've got sodium hydroxide. Well, let's look at the ions, right? We've got H plus, because when you have an acid, you're going to take an H plus off, and that one's gone. What's left? CHO2. And what would the charge on that be? It must be -1, because one of these and one of those made a neutral compound. I don't expect you to recognize that. And sodium hydroxide contains the ions sodium and hydroxide. Then we're going to swap partners, because we have to figure out what the products are. So we've got the H plus and the OH minus, which becomes water. And we have Na plus and CHO2 negative. Is that soluble? Yeah, sodium, soluble. Now it didn't ask us to write the molecular equation, but it can be really helpful to do so. Okay, so which of these are things that are not going to be written as ions? H2O. The only things that get written as ions have AQ after them. And if it's a weak acid, you just write it as an intact molecule. So we know that this is a weak acid. So we're not going to split it up because it only ionizes a little bit. But this is aqueous. So we've got sodium ions and hydroxide ions. And then we've got the water that is not an aqueous, it's a liquid. And then this is an aqueous ionic compound. This is a salt. Are there any spectators? Who's the spectator? Sodium is. Oh, I didn't do that, but I didn't really want to do that. So sodium doesn't change. So that's our net ionic equation. The reason it's not the same, the H plus plus the OH minus, is that this is a weak acid. Any questions?
Why? So why doesn't the CHO2 minus disappear?
The CHO2 minus does not disappear because we're not writing this as individual ions. We're not writing it as individual ions because it's a weak acid. And we know that because the problem told us so. A weak acid stays mostly as intact molecules and only ionizes a little bit. So in the ionic equations, we're showing what most of the things are doing. So most of the weak acid is hanging together. So, the hydrogen ion and the formate ion, they went to the party, but instead of splitting up and mingling, they just kind of went around together, right? Of course, the hydrogen still ended up getting involved with the hydroxides. It didn't help. Any other questions?